Welcome all of my dear students friends to have a video lecture on corrosion and its prevention methods by Cathodic protection and metal spraying. Myself Mr. Z.D. Sande from Department of Basic Science, Anna Sahib Dange College of Engineering and Technology, Ashta, Maharashtra, India. First of all, we should know what is corrosion, meaning and its examples. So first part of my lecture is meaning and examples of corrosion, and then we are going to look into prevention methods of corrosion, especially cathodic protection and metal spraying. Let us see what is meaning of corrosion. Today, all over world, a very big problem for different industries is related with corrosion, and there are thousands and billions of dollars are wasting by different industrial fields for determining and reducing the corrosion. So that's why corrosion is very typical problem we are facing. So what is actually the meaning of corrosion? So you can see here the definition. It is a chemical process caused by the direct chemical reaction or electrochemical reaction of the metal with its surrounding. So here we can say that corrosion is mainly with the metals, and it is due to the surrounding environment. So what is happening in between these two, metal and its surrounding environment? There is a direct chemical reaction or electrochemical reaction, and that's why corrosion is a chemical process. In the same way, we can define corrosion as disintegration or deterioration or destruction of a metal due to the effect of surrounding medium. So what is meaning of this? Disintegration, deterioration or destruction. So here metal undergo chemical change as well as physical change due to the effect of surrounding medium, and there is a problem with the surface of the metal. Surface of the metal get disintegrated, deteriorated or destructed. We can say there are tremendous losses on the metal due to the effect of surrounding medium. So what is surrounding medium? So all of we know surrounding medium may be air consisting of mixture of gases. It may be water vapors. It may be different type of solutions, liquids. Also in different industry, it may be chemicals or like acids, alkalis, etc., or maybe sometimes organic compounds. So corrosion is a very broad term. Now let us see what happens into corrosion. Corrosion, metal gets converted into unwanted material by chemical attack of environment, and the corrosion affects all metals and the alloys. So corrosion is there with each and every metal and also some of the alloys also, but there are few metals which are exception to these, like gold, silver, platinum, noble metals we call. So corrosion is effect on the noble metal is totally, we can say, zero. Now what happens? Metal surface get converted into different chemical compounds due to reaction. Whenever there is reaction, some products are formed. So here oxide, nitrate, carbonate, sulfate, sulfide, hydroxide, like different metal compounds are formed on the surface due to corrosion. For example, consider if there is reaction of iron and oxygen from air, then it will form iron oxide. If there is a reaction of iron with different type of carbon dioxide, for example a gas, it may form its carbonate. In the same way, different compounds will be formed like this. Let us see some examples of corrosion by pictorial view. So you can see here there is a machine part showing different components connected together. So here due to corrosion, it is got converted into totally unwanted surface area, and that's why there is destruction of the metal surface. You can see in the same way, this is a old model car and motor, which you can see here it is on the in the environment and getting totally corroded, and its parts are totally become useless. In the same way, you can see this upper area where there is a bridge based material of a bridge where components have got corroded and it is getting destructed. You can see in this comparison of a corroded iron chain or steel chain, and this is the non-corroded. So you can see the difference in between these two. In the same way, in industrial area, for example, chemical industries and other industries, many fabricated large structures have got corroded, and the effect of this corrosion is like this. And therefore, there is always chances of chemical leakages, fires, accidents, as well as explosions, many times due to the corrosion. And that's why it is very risky to use such components in the industrial field and machines. Now, here we got some idea regarding meaning of corrosion and its examples and what happens during corrosion. Now, we are going to see the second part in today's lecture, prevention methods of corrosion. Prevention methods for corrosion are many in number, but we cannot prevent corrosion of a metal 100%. And it is said that prevention of corrosion cannot be achieved, but we can control corrosion, control the rate of corrosion, speed of by which corrosion occurs. And for that purpose, in our this second part of the video, let us see what are the prevention methods of corrosion. So there are prominent methods of corrosion are like this. Metallic coatings, cathodic and anodic coatings are involved in these metallic coatings. So one metal is coated over another. It may be cathodic metal or anodic metal, which will prevent its corrosion for a long period of time. So best example for this is galvanizing, where zinc metal is coated over steel or iron articles to prevent it from atmospheric corrosion. And these steel rods which are used in RCC construction work are the best example of metallic coating, and where we are preventing its corrosion due to the chemical attack of cement and water. In the same way, tinning is also one of the example of metallic coating where tin is applied. Zinc coating comes under anodic coating, tin coating comes under cathodic coating. There are also examples like organic coatings where we are applying paint, varnishes, as well as different type of chemical components. Nowadays, there are use of nanomaterials to apply as a part in the organic coating, and it will act as a barrier layer between environment and the surrounding medium, environment and the metal itself. Next one is the cathodic protection, and after that anodic protection, then metal spraying, metal cladding. So in today's video lecture, we are going to look over here cathodic protection and metal spraying in details. So let us start with first cathodic protection. For cathodic protection, the principle involved is, you can see here in this protection method, is to force the metal to be prevented to behave like a cathode so that corrosion does not occur. Principle of in this, once again you can see, to force the metal to be prevented to behave like a cathode so that corrosion does not occur. So what is meaning of this? Whenever we use any cell or battery, there are two electrodes, one is anode, second is cathode in electrochemical cells or battery. So always we see that at anode there is a dissolution, or anode get dissolved in surrounding solution. That is nothing but we can say corrosion, and cathode is prevented from corrosion, and the cathode remain as it is many times. So here the same principle is used here. So you can see here this is one of the steel structure to be protected, and this steel structure is immersed or it is present in a seawater. Seawater is a highly corrosive environment. We cannot prevent its corrosion by many different methods. And for that purpose, what is the procedure done here? You can see to this steel structure by using a connection like an insulated copper wire, aluminum anode is connected. So this is the aluminum anode, aluminum metal piece is connected. So what is happening in this environment? So it is just looking like a battery or cell where seawater is used as a electrolyte. Steel structure, yeah, you can see now this steel structure, it will act as a cathode. Why it will act as a cathode? Because steel structure is mainly prepared from iron as a basic metal, and we are connecting aluminum to this. So aluminum is having higher place in electrochemical series or EMF series, and that's why aluminum will be acting as more active metal and iron or steel will act as a less active metal. So in this combination, aluminum will act as anode and automatically we are forcing this steel structure by this type of connection to act as a cathode. So this principle is now satisfied here to force the metal to be prevented to behave like a cathode so that corrosion does not occur. So in this environment, what will happen? Whatever the corrosion is here going to occur by chemical reactions will be only with aluminium, and our main structure will remain safe without any effect of corrosion. So you can see here some reactions are also given, like here aluminium will undergo formation of its ions due to corrosion and form Al+++ ions. Electrons will flow from anode to cathode like this through this anode connection. Meaning of electron flow is nothing but flow of current, and therefore this cathodic protection is mainly we can prevent the steel structure from corrosion. Let us move towards types of cathodic protection method. There are two types: sacrificial anodic, or it is also called as galvanic protection. Whatever we saw the example before this comes under sacrificial anodic or galvanic protection. Now we will look into this same example here. You can see here pipe to be protected, which is under soil. Here it is under soil now. So soil is a very corrosive environment, and here it is the sacrificial anode made up of magnesium metal. It is connected by using an insulated copper wire to this pipe to be protected from corrosion. So in this case what happens? Here we are forming a electrochemical cell where this pipe to be protected will act as a cathode, magnesium metal will act as a anode, and whatever corrosion will be here will be only with this magnesium metal, and there is no any effect of corrosion on this pipeline. Now why this magnesium electrode or magnesium metal will act as a sacrificial anode? Because itself it will undergo corrosion and prevent the main structure from effect of corrosion. That's why here it is called as sacrificial anodic protection. Now here there is a formation of galvanic cell automatically. That's why it is also called as galvanic protection. Let us see the second type of cathode. It is called as impressed current cathodic protection, or simply impressed current method. Again here the same example, pipe to be protected under soil, and it is connected using an insulated copper wire to negative terminal of a direct current battery. It is called a DC current or direct current battery. And positive terminal is connected to a sacrificial anode. Actually here this anode is mainly made up of stainless steel, scrap iron, sometimes platinum also, and it is also called as insoluble anode. This anode is surrounded by a backfill, that is by coke or gypsum. What is meaning of this? Coke means carbon, gypsum means CaSO4 twice H2. This backfill will improve contact of this anode with the soil. In the same way, earthing process in our houses. Now here in the same way, what is happening here? A direct current is passed to this system using this external source of current. That's why forcefully we are making pipeline to act as a cathode. We are sticking to the same principle of cathodic protection here also. If you look into these two type of methods, second type of method, which is impressed current method, is having use of DC battery, and here there is somewhat important to see the working of this battery, monitor its working, whether it is continuously supplying current or not, and underground such type of pipelines can be prevented from corrosion for a long period of time. Now there are tremendous applications of cathodic protection. This is the transmission line towers which is fitted into soil for many years. There are also different variety of towers which are very big metallic structures. We cannot prevent them from any other method. So here cathodic protection is very suitable to prevent them from corrosion of the metal. So here we can apply cathodic protection at the base area of this tower, and we can save it from surrounding atmosphere or gases and moisture or water also. In the same way, marine fittings, that is seawater fitting, for example oil pumping plants, so they are always under very high corrosive atmosphere, and we can save them from corrosion by using this method. So you can see here what are the applications of cathodic protection. Sacrificial anodic protection is applied to buried pipelines, underground cables, marine structures, under seawater structures, ship hulls, that are the bodies of the ships, then water tanks, piers, etc. Impressed current This method is applied to open water coolers, water tanks, buried oil and water pipelines, condensers, transmission line towers, just we saw this example, then marine pipes, ships, etc. So here it completes the cathodic protection method. Let us move towards metal spraying process. What is metal spraying? We saw in our day-to-day life, we spray one oil paint on some metallic and non-metallic structures to prevent it from corrosion as well as to give a good surface properties. In the same way, a process of coating one metal over another by using spraying gun or pistol is called as metal spraying. So we can coat a metal on another metal in this prevention method, and we can apply a uniform coating of that metal and we can save it from corrosion for a long period of time. Apparatus required is spraying gun, which is also called as pistol. Let us see what is this spraying gun and its layout. It consists of a duct for compressed air and it is fitted with oxyacetylene flame. Spraying gun is generally having layout. In this, what is happening? Metal in the form of wire is fed into the gun. Metal wire melts at higher temperature of the flame and comes out in the form of a spray by compressed air. The metal whose coating is to be applied is used in the form of wire, and there is oxyacetylene flame. That is, what is meaning of oxyacetylene flame? Mixture of oxygen and acetylene gases. They are able to produce very high temperature, and at higher temperature of this flame, the metal wire melts. And due to the use of compressed air under high pressure, this melted wire comes out from this spraying gun in the form of a spray or atomized spray. And this spray is applied in the same way just like a oil paint spray, and here we are comparing with that. Now you can see here what is layout of metal spraying gun, though it is showing more complicated, but here you can see now what are the important parts or basic parts. At the center you can see here it is the wire of the metal whose coating we are going to apply on the base material. This is the base material, it may be metal, non-metal, and how it will undergo formation of this atomized spray. It is due to the application of high temperature of oxyacetylene flame which is surrounding over the metal, and atomized spray is formed due to application of compressed air. So this is the third important part, compressed air. And here you can see this atomized spray is applied on the base material in the form of a thin layer over here, which is called as sprayed metal. What are applications of metal spraying? The spraying technique is useful for applying coatings over fabricated structures, ready-made structures. We can apply very large such structures using this metal spraying gun, save them from corrosion for years. The spraying technique is used to coat large and irregularly shaped articles. The spraying is also useful for coating non-metallic materials such as glass, wood, plastic. We can improve surface properties, and we can also make such glass, wood, plastic, their surface is conductive also by using spraying technique. So these are the applications of metal spraying. Hope that in today's lecture whatever we discussed together, that is corrosion, its meaning, its examples, different methods of prevention of corrosion, especially two methods which we discussed today are cathodic protection and metal spraying. Hope everyone has understood well and they will use it in improving your knowledge. Thank you.